Okay, we'll work through the solution to Mechanical Engineering 1230 Statics Quiz 12. We have a beam here. It's a pin connection on the left end, simply supported part way through, and then the right end is cantilever. And we're asked to draw the shear and moment diagrams for the beams. And how we get some points: we find our reactions at A and B. We get 1 point for each of those. We find V and M for the first section, 1 point each. V and M for the second section, 1 point each. So we're up to 6 points total. And then the shear diagram and the moment diagram, 2 points each for those to get us our final 4 points for our 10 points of this. So as we look at this beam, you can see here we have a distributed load. So our first step will be find the resultant load for our distributed load. Step 2, find our reactions. Step 3, we'll split the beam into sections. We do that at discontinuities. Solve for V and M at each section. And then finally 5, we'll draw the diagram. So I'll come over here on the right side and start with step 1 just to make sure I have enough room here. So our distributed load, we have 40 kilonewtons per meter acting over 8 meters. So FR equals 40 kilonewtons per meter times 8 meters. It's a nice rectangular constant distributed load. So that's going to be 320 kilonewtons acting at the midpoint of this 8 meters, so 4 meters. So we've got that section there. Step 2, we're going to find our reactions. So I'll start by finding the moments around A, setting those equal to 0. So 0 equals, we have our first load here is our resultant force from our distributed load. FR, so it's going to be negative 320 kilonewtons times 4 meters, and that negative sign is right. It's going to be creating a clockwise moment, which in our sign convention is negative. At B, we're going to have some reaction here coming up, so we'll have plus 8 meters BY. Then at C, we have two things going on. We have negative 20 kilonewtons. I'll put a plus negative 20 kilonewtons times 11 meters. And then minus, again clockwise, negative kilonewton meter moment there. So the only unknown we have is BY. You can rearrange this. And we find BY equals 206.25 kilonewtons, and we report that out. We'll go to 3 significant figures. So there's one part, so we can get 1 point for that. What else do we have here? We have our Y reaction force at A. So we'll take the sum of the forces in Y, set that equal to 0. 0 equals AY minus FR, which is 320 kilonewtons, plus BY, which is 206.25. So I'm including these figures here just to preserve some accuracy or precision in our calculation. And then we have a negative 20 kilonewtons over here at C. So with all of that, can add this up, bring it to the other side. So AY equals 133.75 kilonewtons, which goes to three significant figures is 134 kilonewtons. Alright, so we're done with step 1 and step 2. Now we're going to split the beam up to sections at the discontinuity. So we have a discontinuity here, but that's where the beam starts. So we'll start there, and this is all a continuous load. It's not changing stepwise. We're going to forget about our resulting force there. And we go up to B is our next discontinuity. So we'll have one section where it's 0 to 8 meters, and then another section from 8 to 11 meters with that discontinuity at B. So we'll have step 3, we'll have 0 is less than or equal to x, which is less than 8. So our beam here, we have AY, I should have written out here the sum of forces in x as well, equals 0, 0 equals AX, so AX equals 0 kilonewtons. That's our third reaction there. Oh. Alright, so we have AY, I'm not going to draw AX on here. We have, this is going to be 40x, and that's operating at x over 2. And then we're going to have our shear on this side, V, our bending moment on this side, M. So if I add up my Y forces, 0, I have AY, 0 equals AY, minus 40x, minus V, can pull V to the other side, V equals AY, minus 40x, AY again was 133.75, so V equals 133.75 minus 40x. It's from 0 to 8 again. And then my moments, I'll sum my moments around this point, right? So equals 0. So I have 0 equals AYX. That's going to be a negative sign. Plus 40x. And this direction here is going to be x over 2 as well. Plus m. So m equals 133.75x minus 20x squared. So that's my m from 0 to 8. So that's the first half of that. Alright, and then the other half is going to be from B to C, so not including 8. So this is going to be from 8 is less than x is less than or equal to 11. So in this case we have this beam here. On this end we have 20 kilonewtons. We have 150 kilonewton meter moment. We're going to have our shear on this side. We're going to have a moment that acts that way clockwise. So if I add up my y forces, they have to equal 0. So 0 equals v minus 20 kilonewtons. I don't have any position dependence on that. So v equals 20 kilonewtons. And then adding up my moments, sum of the moments around O equals 0. 0 equals m minus 150 kilonewton meters minus, and where is this going to be? It's going to be operating at x away, or the length here, so it's going to be 11 minus x from here to there. So m equals I messed that up. So I've got a sign convention wrong here. I should be taking m this point, not including that last 150. So if I don't have the 150 on there, this is going to be a discontinuity at the end. So at the very end, we're going to have a plus 150. So M, basically I just need to pull this M to that side. So M equals negative 150 kilonewton meters minus 220 plus 20x. So that all goes to 20x minus 370 kilonewton meters equals M. So we've got step 4 done. We split it in parts, solve that. Now we're going to draw our diagrams. So our V diagram, let's find where we cross our x-axis. So I'm going to set this equals to 0. So I find x equals 133.75 over 40. And that goes to, let's see, 3.344. And I'm going to start at 133.75. That was a small 3. At this point it's going to be 0, and that's 3.344. And then at my jump here, working backwards at 11, I'm going to have 20. It's working down here, and then I have 206 down, so that's going to be negative 186.25 at B. So I have this area here, and this area here, and this area here, and this is 20, and this is at 11. Oh, this is at 8, excuse me. And this is at 11. So my shear diagram, my moment diagram, so I'm going to have a peak or a trough depending at this point. So I'm going to mark that kind of coming down here to keep track where that point is. At this point I'm going to have a change in my slope as well, or change in my shape. And I'm going to start at 0. I'm going to end at 0. I know on the right side here I'm going to have 150. If I plug 11 into, 8 into this equation, let's see, 8, it's going to be 160 minus 370. It's going to be 210. This is going to be negative 210. This is negative 210. This is negative 150. And I'm going to start at 0. So at 3.34, use this equation, plug that in, I get 223.6. So my it's going to be more of a curve. Sorry about the pen here. So something like that, where it's shaded in here. So there's my bending moment. So that's plus 2 for this, and then for everything else I get 1 point. So that's how we get our points. That's the solution to the quiz. So hopefully that is helpful for all of you.